Mic test, mic test. 1 2 1 2. I think everything is working. Let me go ahead and move my Discord over here. Give me 1 second. Actually, you know what? Let me just. Yeah. Okay. And then let me go ahead and lower the music a little bit. All right. So, what's up, guys? Um, so like I said last time in my last stream, um, wanted to go over the basics of networking. Um, you know, there might be people out there who actually don't know anything about networking, right? Like, you know, probably 90, if I had to guess, like the average person, you know, probably like 90% of folks don't understand how the internet works or like how computers work and things like that. And like don't worry, like I'm still gonna be talking about cybersecurity related things. Um, and still try to do walkthroughs and things like that. But I think what's more important is probably going to be understanding the actual basic fundamentals of network. And I mean, cybersecurity is great. Don't get me wrong. I love cybersecurity. Obviously, that's why I'm studying it. But uh, if you don't know the fundamentals of networking, then how are you supposed to secure that, right? Because cybersecurity, you're securing networks. So, so today's stream, we're probably gonna just cover maybe, so before I even start, so this is by Cisco. Shout out to Cisco. Thank you, Cisco, for making this possible. This is a free resource that you can go on Cisco and download. Networking Essentials, and there is 20 chapters. And we're gonna go through all 20 chapters. Not today, obviously. Uh, not today. And but we will go through all 20 chapters. And and I decided, the reason why I wanted to do this, again, there may be a lot of people that don't know um, networking, but also it's just good for me. They say the best way to know if you know your information, your stuff, is if you can teach it. So Um, that's pretty much why I want to do this. Also, again, um, just want to be able to just document this and be able to show potential future employers, that I don't just talk the talk. I walk the walk. So, uh, but yeah, what are we gonna learn in networking essentials? Well, we'll be able to explain the concept of network communications, explain the basic requirements of for getting online. Uh, we're going to use a tool called Packet Tracer, and we're going to simulate networks with it. Um, you can download Packet Tracer. If you go on Cisco Packet Tracer, you type in on Google, uh, probably the first link, and then there you go. And then you can um, getting started with Cisco Packet Tracer, yada yada. Yeah, so go ahead and watch this installation video. Install Packet Tracer. You can go ahead and watch this video. I'm not going to do that. I'm sure that you guys can just follow the steps and do it on your own. But we will be using Packet Tracer. We'll build a simple home network. We're going to be able to explain the importance of standards and protocols in network communications, explain how communications occur on Ethernet networks, explain the features of an IP address, explain DHCP, DHCP meaning dynamic, uh, DHCP stands for dynamic, oh my goodness, DHCP. Oh, I am mind blanking right now. I am mind blanking right now. Oh my goodness. Do I really have to freaking Google this? Dynamic host configuration protocol. My goodness. See, this is why I need to do this. This is exactly why I need to do this stream and go through this content. It's because I can't even remember the basic dynamic host configuration protocol. Oh, um, explain the principles of IPv4 and IPv6. Explain how clients access internet services. Explain the functions of common application layer services, configure an integrated wireless router and wireless clients to connect securely to the internet, connect wireless PC clients to a wireless router, um, yada yada yada. I'm not gonna bore you. You guys can read this on your own. Um, I think the only thing you're gonna need really, again, this is free. Networking Essentials is free. You just gotta sign up and you'll get it for free. Um, but yeah, what are we going to learn in this module? In chapter 1, what will we learn? We're going to learn network types. We're going to learn data transmissions. Um, we're going to learn bandwidth. We're going to learn the difference between bandwidth and throughput, um, clients and servers, and network components. So let's get right to it. So in 2022, we're living in the era of technology, right? More specifically, the internet. And I think my webcam's a little blurry, so excuse me, let me fix that. Okay, cool. Yeah, so we're living in the age of the internet, right? Um, everything is pretty much done with the internet, and if you're not on the internet, uh, I don't know what you're doing. Um, but yeah, everything's done with the internet. Emails, Facebook, your social medias, when you're ordering, Uber Eats. I mean, watching your favorite show, streaming it. I mean, everything is done through the internet. And so, who owns the internet? Well, it's not owned by individuals or group. The internet is a worldwide collection of interconnected networks. What does that mean? So basically, the internet is just one huge network. This huge network that's built upon smaller networks. And that's the internet. That's how you are able to contact people from Australia. You know, I'm in America, United States, more specifically, I'm in Virginia. That's how I'm able to contact some of my friends who live in California or people who live in, Canada or Korea, vice versa. Um, the internet. Internet's amazing. So, let's get right into it. Local networks. There are different kind of local networks. There's obviously um, like what you see with my room, small home network, just, basically your average user, you know, um, somebody who just has a computer, printer, that's pretty much a small home network. Maybe, well, nowadays, I guess small home networks is like I got a family of five, so, I got my mother, my father, I got two brothers. We're all connected in this network. Um, we got cell phones and iPads and laptops and tablets and smart TVs, like all that stuff, right? That's all connected into this small home network. So if you have a router and you have internet and you have a PC, you have a network. Small office and home office networks, or more commonly known as SOHOs. Yeah, self-explanatory. Just, small offices. Like, think of your libraries, I guess. You go to the local library, you see like those publicly computers, the computers that are available for people to use publicly. Yeah, think of that. That's kind of like a small office and home office network. Um, Small businesses. Nowadays it's kind of like the small home network and the small office home network. I mean, I guess they're starting to be, interchangeable. I mean, nowadays because people work from home, so, but know the difference between these two. Then there's the medium to large networks. You could probably think of like, yeah, schools, um, uh, companies that have, hundreds of employees, and then you have um, the worldwide network. This is the internet that we just literally talked about, right? The internet. What is the internet? Who owns the internet? So that is a worldwide network. And then they talk about mobile devices. I don't think I need to really get into this. I think we all know what a smartphone, a tablet. Look at that tablet. Like smartwatches. I mean, I remember when smartwatches used to look like this. And like, what was that, like 2014, 2015? I mean, feels like so long ago. But I mean, I guess 7 years is quite a bit of time. But I just remember this was so like innovative. Like, oh my gosh. And then smart glasses, like, remember Google had their smart glasses? I mean, jeez. Anyways, I don't have to, I'm gonna skip over this. Um, Security systems, nowadays people have Ring, like when you go to the door and you see like that little camera, the Ring camera system. Smart TVs, like I said, I think I mentioned it earlier in the small network, your home network, you got TVs, you got appliances now, like refrigerators and washing machines and what are those the vacuums, those vacuums that literally just bounce off the walls and move around, like, and then even gaming consoles, PlayStation 5s, I don't know what the new Xbox is, Nintendo Switches. Yeah. um and then there's smart cars. Anything that has like that dashboard, not dashboard, the touch board, smart cars. We all know, excuse me, we all know what smart cars are. RFID tags, radio frequency identification tags. Um, where would you see this? You know what? Let's just look it up. Where could we? Where are RFIDs normally used? Most common in hospitals. Okay, let's look. The most common RFID applications in Okay, we'll talk about hospitals. There's tracking. Okay, so tracking, um, passports. Wow. Um, let's see. Sports facilities. Um, yeah, like badges, I guess. So yeah, I think you guys understand. Sensors and actuators, medical devices. Okay. What type of network allows computers in a home office or remote office to connect to a corporate network? Wait, so what type of network allows computers in a home office or a remote office to connect to a corporate network? I believe that's medium to large network. What can be placed in or on a package so that it can be tracked? RFID tag. Let's check. Okay, I was wrong. What type of network allows computers in a home office or a remote office to connect to a corporate network? Is that going to be the worldwide network? That is not the worldwide network. Small office. Okay, let's see why. Small office network allows computers in a home office or remote office to connect to a corporate network. Okay, I think this is kind of stupid. I don't. That's kind of stupid. And I'm not saying it's stupid because I got it wrong. I just think that's like not right. So there are three types of data. Excuse me, three types of personal data. Um, First one being volunteered. Uh, so volunteer data is like when you use Instagram and you upload your photos, you're 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 volunteer like nobody told you to upload those photos, right? Or when you go on Facebook and you open this and then you share status, like those kind of things are you're voluntarily giving away data, right? Nobody asked you to post it. You're just doing it. Um, Observed data. This is captured by recording the actions of individuals, such as location data when using cell phones. And then infer data. This is data such as a credit score, which is based on analysis of volunteered or observed data. The bit. Basically, bits are either going to be 1 or 0. One, think of 1 being on and 0 being off. Um, and this is how computers work, right? Like when I'm speaking right now, I'm using a language. The computer's language is in binary, zeros and ones. That's how a computer speaks to another computer. Computers don't speak using English like how I am. Computers speak in numbers, more specifically in binary, zeros and ones. Um, Computers use okay, so computers use binary codes to represent and interpret letters, numbers, and special characters with bits. A commonly used code is the American Standard Code for information interchange. Oh, a commonly used code is the American Standard Code for information interchange. ASCII. With ASCII, each character is represented by 8 bits. And just to let you know, 8 bits is known as a byte. So a byte is 8 bits. And you don't really need to know this. Um, Common methods of data transmission. So I think we all know there's something called Ethernet cables, right? Um, and then there's fiber optic cables, and then now we're in the era of Wi-Fi. Um, So there are three common methods of signal transmission. So basically, when computers send these binary digits, these bits, they have to use some sort of transmission, right? And these transmissions can be either electrical signals, optical signals, or wireless signals. So electric signals, think of like your coaxial cables, your copper wire cables. Um, Optic signals using light, such as fiber optics, and wireless signals using infrared, microwave, or radio waves. Um, I guess we can watch this. So yeah, hopefully you got that. Let's check our understanding. A basic unit of info that represents one or two discrete state is known as a bit. Remember, byte is 8 bits. octet. I don't even think we learned any. I don't think we even learned an octet yet. And electric signal is not one or two, right? So wait, did they talk about octets? I don't think they talked about octets. No, I don't think they did. No, I don't think they did. But yeah, I'm gonna go with bits. When using your credit card to make purchases at several places, the credit card company can use this information to learn about your location and your preferences. This type of personal data is known as inferred because um, this is not volunteer data. Again, volunteer data is like, again, people using social media and stuff like that. Observed data, um, it could be observed data, um, but I think the key here is the credit card company can use this information. Well, the credit card company is observing you purchasing at several places, and then they use that data, that information, right? They look at this credit card company looks at, okay, Moses is going to I don't know, Nike, and he likes to go eat at Korean restaurants, and he likes to go and I don't know, buy, it's all sorts of things. I'm sorry. Anyways, the credit card company is pretty much observing what I'm doing, right? And then they're gonna learn about my location and my preferences. So this is most likely going to be inferred data. And then, which of the following methods of signal transmission uses frequencies or pulses of light? It's gonna be optic signals. Let's check. And three for three, baby. We are three for three. So again, three common methods: electric, optical, and wireless. Um, bits. Bits are zeros and ones. That's how computers speak with each other. It's through bits. And 8 bits equals 1 byte. And the types of personal data: volunteered, observed, and inferred. We are rolling. All right. Bandwidth. So, bandwidth and throughput. There is there's a difference, right? I think a lot of people think bandwidth is internet speed, and people commonly associate bandwidth with internet speed, and that's not necessarily true. Um, like, when people say, "Oh, you got high bandwidth, dude," and that they think like, "Oh, you got fast internet." Um, again, which isn't necessarily true. Um, think of bandwidth is it's the amount of data uh, that can transfer, right? So think of it as um, like your shower faucet, right? And the water that's going through, right? That's the data, right? Think of the water as your data. The smaller that faucet head is, the less bandwidth you have, meaning the less water that can go. But if you have a larger shower head, hence more bandwidth, more water can pass through, which can then therefore lead to faster internet speeds. Um, so yeah, bandwidth is the capacity of a medium to carry data. Um, Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. Bandwidth is typically measured in number of bits that can be set across the media in a second. So again, think of bandwidth as like um, bandwidth is again is it's more about um, how it's again, it's not speed. It's just how much data can this can go through, right? Again, using the shower head example, the larger the shower head, the more bandwidth you have, because that means more water data can go out. Throughput, like bandwidth, throughput is the measure of the transfer of bits across the media over a given period of time. However, due to a number of factors, throughput does not usually match the specified bandwidth. And many factors can include the amount of data being sent and received, the types of data being transmitted, the latency created by the number of network devices encountered between source and destination. And latency refers to the amount of time, including delays, for data to travel from one given point to another. So, latency, think of it as like lag, you know, think of it as lag. Enough, Brave. So, let's check our understanding. The capacity of the medium to carry data is known as bandwidth. Which of the following measurement includes any latency encountered during transmission? This is throughput. And bandwidth is typically measured in, I think it was bytes per, by, was it bits per millisecond? Let's, sorry guys, you know what? Let's go. Bits per second, bits per second. Sorry guys, bits per second. We are almost done with this chapter, guys. Client and server roles. So, what's a client? I'm a client. You're a client, right? Like so right now, I'm every time I go to google.com, I'm the client and I'm using the internet to get to google.com. Google.com being the server. Um, and the main difference is going to be the software installed on the computer. So servers, people have this like misconception of like a server. Just a server is a computer. It can be like uh, a normal computer or it can be a supercomputer, right? If you think of like large data centers, they're using supercomputers. But servers, again, servers are computers, and these servers have specially installed software, and 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 they offer a service, right? Server service. Think of server service, right? These servers are offering a service. And we as clients, every time I go on the internet and I go to Nike.com, I'm accessing Nike's server and and that's how I'm able to browse the website, right? It's not like Nike is not just this floating thing. There's a computer hosting the website. And it's not just a computer, right? It's a supercomputer. And they probably have several supercomputers. You can imagine Nike being a huge company. They probably have uh, several supercomputers. Amazon. Amazon's a server, right? AWS. They have, I believe Amazon is the biggest cloud provider in the world. I think they own more than 50% uh, of the cloud of the cloud. Yeah, and then I think it's Google and then Microsoft. I could be wrong with two and three, but I know for sure Amazon is dominating the market. Um, so yeah, let's look. Types of servers: email servers, um, like I said, web servers, and then file servers. Um, Google Docs, right? When you when sorry guys. Let me go ahead and um, Google Docs, that's a file server. Uh, Gmail, email server, and Google.com, web server. Peer-to-peer networks. So let's see. Client and server software usually run on separate computers, but it's also possible for one computer to run both client and server software at the same time. It's it's like uh it's like our computers, guys. Our computers can do several things at the same time. Um, Multiple PCs. Okay, sorry. The simplest peer-to-peer network consists of two directly connected computers using either a wired or wireless connection. Both computers are then able to use this simple network to exchange data and services with each other. So again, the simplest form would be here's this printer, it's connected to this PC, and here's another computer, and it's like, hey, I need to print. So it's like I have this file that I need to print, and I'm gonna send it to this PC who's connected to the printer, and he's like, hey, and then so this guy will be like, can you print this for me? And then this PC will go and tell the printer to go ahead and print it. Uh, let's see. The advantages of peer-to-peer: easy to set up, less complex, lower cost because network devices and dedicated servers may not be required. Can be used for simple tasks such as transferring files and sharing printers. The disadvantages: there's no centralized administrator. It's not secure and it's not scalable. Peer-to-peer application. A peer-to-peer application allows a device to act as both a client and a server within the same communication, as shown in the figure below. In this model, every client is a server and every server is a client. So think of it as like it's kind of like text messaging. Not like text messaging. That's a bad example. Um, what's that app called? Oh man, I have it. Let me look it up real quick. Signal, the app Signal. I don't know if you guys have. So I don't know if you guys have ever seen Signal, but it's pretty simple. I'm not. Um, Actually, I don't know if I could show you this. There's a lot of people that are on it that I think wouldn't appreciate me putting them on internet. But Signal is like an app. You know what? Let me just pull it up, right? There's one way to do it. Signal app. Here we go. So it's literally um, there's no servers, like there's no third-party servers involved. Like Facebook messaging, that is not peer-to-peer because you're using Facebook server. Um, Signal, um, let's say my friend texts me, I'm the only one. Well, us two, my friend and I, we're the only two people that have the text messages. There's no other person or entity that's gonna have that information. Um, I wish I could think of like another example for peer-to-peer, but Signal is the best one that I can think of at this moment. Just think of it as there's just no third party. It's literally I'm the server and client. So I'm the only one that hosts all the data, and my friend who texts me, I'm the only one that has that text besides that other person. There's no third party server that's gonna have that information. And then you can see like Edward Snowden uses it, Jack Dorsey, CEO. This is pretty outdated. He's not the CEO of Twitter anymore. They should update that. And then let's move on to multiple roles in the network. So yeah, like I mentioned, a computer can be many things, right? Like Google, again, going back to Google, I know I've been using Google, but Google is multiple servers. And speaking of Google, my phone just turned on Google. So when you think of Google, there's Google Docs, which is a file server, Gmail, and Google.com, right? And and again, Google, stop it, Google. And so this client can act. So here's this one server that's running as multiple servers. It's offering multiple services. And here are four different clients who are using this server for, look, and this one is using it for files. This one is just using it for browse the web and trying to get he or she's emails. This one too is just on the web trying to get some files. And this one's using it all. And here's this, and so a server can have multiple roles if it has the resources to do so, the capabilities to do so. Let's check our understanding. A computer that has a software installed to provide information, such as email web pages to other devices, is known as a server. It's providing information. So it's providing a service. Smartphone uses web browser software to request and display a web page. A smartphone is considered what type of computer? When think of requests as clients request. A network where two computers communicating with each other as both a client and a server, that's going to be peer-to-peer. Let's check. And 3 for 3. Network infrastructure. There's three parts to a network infrastructure. That's going to be, here's the bottom layer, right? The bottom layer being like your cables, or your like think of the network, the this bottom layer, the network media layer. That's where you're gonna get your Ethernet cables, your coaxial cables, um, your wireless, and then the intermediary devices. This layer. This is where you start thinking of your routers, your switches, um, and then end devices. Think of your your PC, your smartphone, anything that like is like at the end of how do I describe this? Just think of your phones, like think of that, right? Your phones, your smartphones, your laptops, your PCs, your gaming devices, printers, smart TVs. Those are gonna be end devices. Um, Geez, Brave, how many times are you gonna remind me? So these are the three components that are gonna make up a network infrastructure. And let's get right into the end devices. Network devices that people are most familiar with are called end devices, or aka hosts. And again, I'm not trying to be a broken record. Think of your computers, your printers, your laptops, your smartphones. Let's see, what do they want to show in this video? Okay, so here's one end device, right? Here's an end user, a host, and they want to send information to another local area network. And so they're sending their data, and here's a router, right? The intermediary device, the device that's the middleman that's going to deliver the packet. So in this case, they're using a router. And this router, so, so, sorry. Here's the end user, and here's another intermediary device, the switch. So this switch forwards the data, the packet to this router, and then this router, so we haven't gotten to yet, but this router is gonna look at the destination IP address and is gonna be able to determine, okay, which router am I going to use? Which is the best path for me to get this packet to the destination. So it's deciding, okay, what's the best path, and it decides that's the best path, and then it sends it to the switch, and then the switch looks and it sees the destination MAC address, and then it sends it there. We haven't gotten to IP addresses and MAC addresses yet, um, but that was a quick example of how packets and data are sent over the network. Which two devices would be described as intermediary devices? Let's see. Laptop, nope. Smartphone, nope. Self-driving car, nope. Server, nope. Switches, yes. Firewalls, probably. Server, again, server, like we said earlier, like we talked about earlier, servers are a computer. It's another end device. So with the process of elimination, we're probably going to go with these two. Which two devices would be described as intermediary devices? Okay, again. All right, so routers, probably yes. Assembly line robots, I don't even think we even need to think about that. Laptops, nope. Cameras, nope. Servers, nope. Wireless local area network controller. Again, with the process of elimination and using educated guess, it's probably gonna be these two. Even though I want to choose assembly line robot, tempting. Which two devices would be described as end devices? Uh, Servers, again, we talked about server being a computer, computers, end device. Access point, probably not. Switch, probably not. LAN controller, well, if we chose it for an intermediary device, it's probably not an end device. Router, I mean, we chose a router for an intermediary device, probably not. So, fitness monitor, probably. I think we discussed it back in like what 1.1 or something like that. Health devices, I think that's a good choice. Okay, another two intermediary devices. Router, yes. Uh, Wireless LAN controller, yes. Camera, no. Server, no. Self-driving car, no. Laptop, no. These are getting pretty redundant. Intermediary device, again. Routers, yes. Switch, yes. No, 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 no. Okay. Switch, yes. LAN, yes. PC, no. Self-driving car, no. Camera, again, no. Gaming camera, no. End device. Server, yes. Maybe a camera. LAN switch, no. Wireless local area network controller, no. Access point, no. Router, no. So we'll go with the camera. Assuming that they're talking like a Ring device camera, right? Like the Ring cameras that you put at the door. Which two devices are end device? Gaming console, okay, we'll probably go with that. Retail scanner, maybe. Firewall appliance, no. Wireless router, no. Access point, no. Multi-layer switch, no. So we'll go retail scanner. Which two devices would be described as end devices? Printer, yes. Maybe self-driving car. Firewall, no. Switch, no. LAN controller, no. Router, no. So we'll go with the self-driving car. And which two devices? Intermediary. Switch, yes. Router, yes. Camera, no. Server, no. Printer, no. Okay. Moment of truth. 10 for 10, baby. 10 for 10. Let's go. Easy. And that is the end of this chapter. And what did we learn? We learned network types, we learned data transmissions, we learned the difference between bandwidth and throughput, clients and servers, and network components. And I'm gonna leave this quiz to you guys to do. Um, and the next stream will probably go over chapter two, and chapter two is going to be talking about online connections. I think next stream we'll do chapter two. Um, maybe maybe we might do some ethical hacking again. I'm not sure, but like I mentioned earlier, way earlier in the beginning of the stream, I think just learning the fundamentals and the basics of networking is very, very important. So, for the sake of continuity, we'll probably go with networking again. I hope this was informative, um, and I hope I didn't bore you guys. Um, but yeah, I hope you guys had a great time with me. I know I did, and till the next time, thanks for stopping by, and hope to see you again. Peace.